Oh, hi!
Oh, hi!
Welcome to the Empirical Rule video. If you understand all these references, you're probably very excited, and if this shirt means nothing to you, I'm sorry. I actually didn't go to the Eras tour. I wasn't really a Swiftie when the tickets became available, and by the time I was a Swiftie, it was like, this isn't gonna happen. So in this distribution, each dot represents one concert from the Eras tour. I'm not gonna lie to you, I made all of this data up. I mean, I did look up the typical length of her concert, and it's 195 minutes. Sometimes it might go a little long because of technical difficulties. And sometimes it might run a little short, maybe just because, you know, the acoustic set is a little shorter than usual. The mean of this distribution is 195 minutes, and the standard deviation is 1.84 minutes. Taylor is consistent, okay? To keep things simple, let's just call it 1.8. You'll see why later. Okay, here is that same distribution, but this time standardized. So, like we learned in the last video, all the data points, we've subtracted the mean of 195, which has recentered the entire thing at 0, and then we divided all the data points by the standard deviation of 1.8, which turned the new standard deviation into 1. Now, the shape of this distribution is unique. It is symmetric, but it is also sort of a bell curve. And that bell curve is so useful and common in statistics that it gets its own name. This is called the normal curve, and it's so important that it's not normal with the lowercase n, it is normal with an uppercase n. Nice. A normal curve is symmetric and bell-shaped, which means most of the data is right in the middle, a lot of it is really close to that center, and then the further out you go, it kind of tapers off into this bell kind of curve. The normal curve just shows up a lot when we look at data sets. Like a really common example is height. The majority of people are around average height, and then as you get taller or shorter, there's like fewer and fewer people that are extremely tall or extremely short. Now this is a standardized normal distribution. So not only is it normal, we have standardized the values. So we've got the mean right here at 0, and then we've got 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. So for Taylor's concerts, we could also put in the actual number of minutes instead of the standardized number of minutes. Like the actual mean was 195. One standard deviation above, we add on 1.8, so that would be 196.8. Two standard deviations above, not me using a calculator for basic addition, and then another plus 1.8. And then we can do the same thing, subtracting 1.8 3 times. Did that work? I don't know if that worked or not. We'll see when I edit. Now, when we have a standard normal distribution like this, we have something called the empirical rule, which helps us answer questions about how long Taylor's concerts were. This is how the empirical rule works, and it works for all standard normal distributions, not just the Taylor Swift ones. Okay, part 1. 68% of the data is within one standard deviation of the mean. In Taylor's case, that means 68% of concerts were between 193.2 minutes and 196.8 minutes. Okay, part 2. 95% of the data is within two standard deviations of the mean. So that means 95% of Taylor's concerts were between 191.4 and 198.6 minutes. Last part. 99.7% of the data is within three standard deviations of the mean. So 99.7% of Taylor's concerts were between 189.6 minutes and 200.4 minutes. 99.7, that's basically everything. And as you can see from this drawing, it doesn't even look like there's anything above 3 or below -3. It was very rare that her concert would be longer than 200.4 or shorter than 189.6. We can use this to answer questions about Taylor's concerts. For example, what percent of her concerts were longer than 196.8 minutes? Well, 196.8 minutes is one standard deviation above, and I want to know what percent of concerts are longer. So basically, I'm looking for the area under the curve to the right of 1. Now, under the curve is all of the concerts total. So the area under this entire curve would be 1 or 100%. But I just want to find the percent of concerts in this, I'm going to call it a tail, this little tail part of the graph. So I know that 68% of the data is between -1 and 1, right? So if I want this tail right here, I could start by taking 100 minus 68. So 100 minus that middle chunk, and that would give me 32. So that basically tells me that 32% of the data is in these two tails, this one and this one. Everything but that middle 68%. So if I just want the top tail, I'd have to take that 32 and divide by 2. So 16% is that tail. In context, 16% of Taylor's concerts were longer than 196.8 minutes. Your brain might have thought about this a different way, and if this is confusing, feel free to ignore. But another way of thinking about it, to find that same tail, we know that this is 68%, so this chunk right here, chunk, technical term, this chunk would be 34%. And I know that from here to here is half the distribution, so that's 50. So I could do 50 minus 34, and that would get me 16 as well. So kind of two different ways to think of it. The first method is maybe like the holistic approach, and this yellow method I drew is more like the 50% approach, like you're just thinking about the top half of the distribution. Okay. Let's do a different one. What percent of Taylor's concerts are less than 191.4 minutes? So 191.4 is 2 standard deviations below, so -2. I know that this area here within 2 standard deviations is 95%. So I'm going to start by doing 100 minus 95. That would give me the area in these two tails, this tail and this tail. Everything but that middle 95% chunk. But I only want this lower tail. So I'm going to take the 5 and I'm going to divide it by 2. So 2.5% of Taylor's concerts are less than 191.4 minutes. If you liked the sort of 50% way of thinking about it, you could also do it this way. 95 divided by 2 is 47.5. So I want this tail, and I know that this chunk here is 47.5. So I could do 50 minus 47.5, and what do you know? You get 2.5%. Okay, let's do one that isn't so nice and symmetric. How about what percent of her concerts are between 193.2 minutes and 198.6 minutes? Well, 193.2 is 1 standard deviation below, and 198.6 is 2 standard deviations above. So see how this is like not centered around the mean? It's sort of like uneven or not symmetric, this section that we're looking for. We want to know this entire area. So with these types of problems, what I like to do is split them into 2 parts. First, I'm going to find this chunk, and then I'm going to find this chunk here. Okay, so let's start with this blue piece. It's 1 standard deviation below. I know that 68% of the data is from -1 to +1. So -1 to 0 would be half of that. That's 34%. Okay, and then this green chunk goes from 0 to 2. I know that 95% of the data is from -2 to +2. So I'm only interested in half of that. So I would do 95 divided by 2, 47.5%. So now I'm going to add those 2 pieces together. 34 plus 47.5, 81.5%. Let me double check. Okay, that's right. Nice. So that's the strategy I would recommend if you get a problem where it's not like perfectly centered around the mean. Try splitting it up into 2 parts. There's pretty much always 2 ways to do these problems, so don't be discouraged if someone else does it a different way than you. It doesn't mean you're wrong. Okay, you know how to use the empirical rule now. Nice! Welcome to the empirical tour video. Empirical tour. Welcome to the empirical... Oh my god, I think, is my brain broken?